Hi everyone, this is the first video for week 2. Let's quickly recall what we covered in week 1. The most important thing was the development of trigonometric ratios, understanding where they arise in a triangle, and then transferring them into functional language. Where remember that the basic definition of a function is that it's a box where you get an input and an output. We usually denote input by x and output by y. We have an additional rule which says that every input must have exactly one output. Okay, these are important because they are fundamental building blocks in mathematics. Now note that the rule for function does not require that for every output there is exactly one input. Okay, so think about it for a minute. These two statements are completely different statements. To say that every input has exactly one output is not the same as saying that for every output there is exactly one input. Here's an example. Consider y equals x squared. Then for every x there is a unique y. Meaning, for example, when x is 0, 0 squared is 0. When x is 10, 10 squared is 100 and nothing else. There is no ambiguity. But if you look at output, how many ways are there to get an output of say 4? Then there are two ways. 4 can be obtained as an output for two inputs, 2 and negative 2, meaning 2 squared is 4 and negative 2 squared is 4. Right? So this means that for a function, we don't necessarily have this rule that for every output there is exactly one input. And the reason we discuss this is because an important class of function that arises naturally called inverse function will have this added rule that every output has exactly one input, corresponding input. Such functions, which you covered in Math 103, are called 1-1 function. And so there is a strict 1-to-1 faithfulness between the input and the output. Functions that satisfy these, they are said to have inverse. Now recall this definition again from Math 103. This is the mathematical way of saying what we just discussed. A function f of x has an inverse function g of x if for any given x, meaning for any input, f composed with g is the same as g composed with f, and it gives you back the input. It gives you back x. So in some sense, the function and its inverse, they cancel each other out. So it's like opening and closing the door. And so whatever state the door was in before, if you open and close it, it goes back to what it was. That's how these functions and inverse functions work. So in terms of our function diagrams, if I have a block f which takes an input and an output, the inverse function, what it does is it takes the output from the function and it returns the input. So it takes the output as input and it returns the output. In Math 103, you learned some of these facts about functions and inverses, but you don't necessarily have to recall them from Math 103. You can reference this diagram to fill out this. I'm going to answer some random ones here and then let you fill the remaining. The input of f here is coming out as the output of f inverse. So the input of f is the output of f inverse. The domain of f inverse. Now recall, what does domain mean? Domain means the set of inputs. So we're talking about the inputs or the set of inputs of, set of inputs of the inverse function. Let's go up here. What is fed into the inverse function is the output of the original function. So the set of inputs is going to be the set of outputs. So this is going to be the set of outputs for which we have a special name called the range. So fill these three, and if you have any, so it's going to be corresponding to how we fill these two. So just look at this diagram and that should help you out. Now again, these are some things that you covered in Math 103. We're going to go over them quickly. There's a very simple test. It has a name as well, horizontal line test. Tells us if a function has an inverse or not. Yeah. So basically what it says is, take the graph of the function and at different levels draw horizontal lines and look at how many points of intersection there are. So each horizontal line intersects. If it intersects exactly once, or let's say not more than once, then it has inverse. So this function has an inverse. Whereas, let's say this function, a horizontal line has 4 intersections, so it has no inverse. Similarly, this function here, which is absolute value function, has no inverse because it has 2 points of intersection. So why does this test work? If you think about it, drawing a horizontal line is basically specifying an output. So this says this function has an inverse because for every output I take the intersection point and I go down to x-axis, that's my input. But for the ones that are not, if this is the output, there are 2 corresponding inputs. Similarly, this here is a parabola which is some form of y equals x squared, and as we saw before with the squaring function, the input is not unique, so it does not have an inverse. So this is a simple test. So that's a recap of the toolbox required for inverse functions. So natural question is, well, the reason we went through all of that is we just recently learned trigonometric functions. So we're going to apply that to trigonometric functions so that we can have inverse trig functions. So let's start with the sine function. Step 1. Does it satisfy the horizontal line test? Now recall that the graph of sine is periodic and looks like that. So it's pretty obvious that if I draw a horizontal line, there are infinitely many points. So the answer is no, it does not. Well, that could be the end of the story. However, we do want an inverse trig function to exist because as we'll find out, it's very helpful. So we're going to fix it. Now how can we fix it is we look at the sine graph and we try to find, let's say I draw the entire sine graph here, so along the x-axis and along the y-axis. Now here I'm going to try to find some interval where if I draw the horizontal line, it does not intersect 2. So for sure I cannot have this loop. Yeah, if I have this entire loop, it's always going to intersect in 2 places. Similarly, I cannot have the lower loop. So whatever I select has to not have a complete loop. Now in addition to that, I want it to go from 1 to -1 so that all possible outputs of the trig functions are considered. So keeping that in mind, we're going to cut this graph right here. And what do we cut it is -pi/2 to pi/2. That's the value 1 here, and that right here is -1. So what we have done now is we took the sine graph and we chopped off all the parts that were causing problems, and then we fix it. So now this has an inverse. Careful that this is not the inverse functions graph. Yeah, this is just us fixing the sine graph so that it passes the horizontal line test, which means that it has an inverse. So another way to say that is that remember, these are the inputs, which means that these are the outputs of the inverse function, yeah, inputs of the original function. So this means that the range of inverse sine function is always between negative pi over 2 and positive pi over 2. Later on, we are going to learn how to look at other angles, because sometimes you may be looking for angles in the third quadrant. But those can be obtained using the periodic property of sine. But for the purposes of the inverse function to be well defined, we have to restrict it to negative pi over 2 to pi over 2. Okay, last bit for this video is try to perform similar analysis for inverse cosine and inverse tangent. Now, one word about notation. These inverse trig functions, you will see them written usually even on calculators in this format, and you read this as sine inverse, cosine inverse, tangent inverse. In old textbooks and in some places, you will see the use of arc sine, arc cosine, arc tangent, which just means the inverse function. Now, these first notations, these are more popular, but they can be confusing because this -1 in the exponent usually means reciprocal in algebra. But remember that this is an error. Yes, sine inverse x is not 1 over sine x. It's a poor notation, but the arc version is preferred one. I'll try to mix both of them throughout the notes and videos just so you're familiar and comfortable with using both. And if either of them appears, you know what's being talked about. That's the end of first video for day 1. We just sort of introduced recapped inverse functions and introduced inverse for trig. In the next video, we're actually going to look at how to evaluate these functions, and then further on we're going to understand what it really means. Okay, that's it for this